Dear GATE aspirants, welcome to Veda GATE Academy, your one and only destination for GATE and IAS coaching. In the last class, if you observe, we were discussing the basic signals or standard signals, in which we completed the first basic signal, which is nothing but continuous time unit step. Now we'll proceed with the rest of the basic signals. Now, I'm not going to say which signal we are going to discuss, but we'll do a small experiment, and after that we'll arrive at the signal. What is that experiment you are doing? Observe here. Listen carefully. If I ask you, what is this signal? And this is nothing but the previously discussed signal, continuous time unit step, U of t. Fine. After this, if I ask you, what is this signal? Do you know what is this signal? This is nothing but the time reverse version of the unit step signal denoted by U of minus t. And if I ask you, what could be this signal? If this is U of minus t, the third signal is minus U of minus t. Now do one thing. Try to add the first signal and the third signal. First signal and the third signal you try to add. Then what is that you are going to get? The resulting signal can be shown like this. For t less than 0, observe here. For t less than 0, this value is 0. This value is minus 1. 0 plus minus 1, minus 1. For t greater than 0, what is the value of this signal? 1. What is the value of this signal? 0. 1 plus 0 is 1. So this is the resulting signal, which we call by the name Signum function. What is the name? Signum function. So let me write here Signum function. So the second basic signal, what we are going to discuss is Signum function. Now this Signum function is denoted by Sgn of t. Sgn of t. And how we obtain the Signum function? By adding U of t and minus U of minus t. Remember, U of t plus U of minus t is 1. U of t minus U of minus t is Signum of t. So let's put this one in a box like this. Now how you are going to define this Signum function? I can define the Signum function like this. Signum of t is nothing but 1 for t greater than 0, minus 1 for t less than 0. Then what about 0? At 0, if you observe, we have sudden rise in the signal. Sudden rise in the signal is termed as what? Discontinuity. In the previous signal we have seen. And I said that whenever you have discontinuity, how to get the value of the signal at that point? Simply take the average of the values according to Gibbs phenomena. So it is nothing but 0 at t is equal to 0. This is the definition of Signum function. Right? After this, observe here. One more small experiment I want to conduct, that is like this. Again, if I ask you, what is this signal? You will say that, sir, this is continuous time unit step signal, which you have already seen. Suppose if I ask you, what is the shape of the signal 2u of t? 2u of t is nothing but the amplitude scaled version of u of t by how many units? 2 units, like this. Now, if I ask you, what is the shape of the signal y of t is equal to 1? What is the shape? Y of t is equal to 1 means a DC signal. Here 1 means no t greater than 0, no t less than 0. It is 1 throughout the interval. Now this is u of t, this is 2u of t, this is a signal called 1. Now do one thing. Try to subtract this bottom signal 1 from 2u of t and observe what happens. What I am saying? Subtract this 1 from 2u of t and observe what happens. So if you observe, for t less than 0. For t less than 0, this value is 1. Sorry, this value is 0, this value is 1. 0 minus 1, minus 1. For t greater than 0, what will happen? This value is 2, this value is 1, 2 minus 1 is 1. So if you observe, this is again our signum of t, signum function, or your signum function can also be written as 2u of t minus 1. Signum function can also be written as 2u of t minus 1. So, what is the other way of writing signum t? U of t minus u of minus t. And I am going to give two more forms of writing signum t. They are like this. Signum t can also be given as t by mod t for t not equal to 0, and it is 0 for t is equal to 0. You observe, you try to get the shape of the right hand part and see whether it is equal to signum or not. You can verify. Or your signum t can also be written like this: mod t by t for t not equal to 0 and 0 for t is equal to 0. Okay, this is about this signum function. And after looking at the definition, the next thing is we'll see what transformations of the independent variable we can perform. Time shifting, time reversal, time scaling. How to perform on this signal called signum we'll observe. So coming to the first transformation of the independent variable, time shifting. Time shifting for signum. So time shifting. Observe here. Suppose if you are given signum of t, try to get signum of t minus 1 and signum of t plus 1 also you try to get. Signum of t plus 1. Now signum t means, what is the shape? This is the shape. Signum t. Signum of t minus 1. Signum of t minus 1 means delayed version of signum t by how many units? 1 unit. So it will look like this. This is signum of t minus 1. In the same way, can you get signum of t plus 1? Yes. Advanced version of signum t by 1 unit. We know that delay means right shift, advance means left shift. It will come like this. This is 1, this is minus 1. This is signum of t plus 1 we got. And after this, time shifting is done. So there is, no complexity in performing time shifting for the signal called signum. Now we'll see what happens with the time reversal. So time reversal I am putting here. Time. Hope you remember what is time reversal. Time reversal means mirror image along vertical axis. Amplitude reversal means mirror image along horizontal axis. So signum t is there. So try to perform signum of minus t, time reverse version, and from this you try to get what is minus signum of minus t also, so that we'll see whether we can make some analysis or not. Let's write signum of t. Signum of t means your original signal. Yes. Signum of minus t means mirror image along vertical axis, or simply folding the signal along vertical axis, or just flipping the signal along vertical axis. Now what will happen? This is signum of minus t. Hope you understood. Take the mirror image along vertical axis. This comes here, this goes here. Now you try to calculate minus signum of minus t. Minus signum of minus t means what? Do this time reversal. Take the mirror image along horizontal axis. Horizontal axis means it will come like this. It will go like this. Now if you observe, minus signum of minus t is same as signum of t. minus signum of minus t is same as signum of t, right? This is signum of t. This is minus signum of minus t. So, okay, if I call this signum of t as x of t, if I call this as x of t, here x of t is same as what? Minus x of minus t. Minus x of minus t, right? So, remember, signals which satisfy this property, x of t is equal to minus x of minus t, are known as odd signals. Anyway, we have separate discussion on even signals and the odd signals, but for the timing, remember that signals which satisfy this property, x of t is equal to minus x of minus t, are said to be odd signals, and our signum t fall in this category. Signum t is odd signal. In the same way, even signal also we have. Even signal means x of t is equal to x of minus t. This is the definition of even signal. This is even, this is odd definition, right? So, signum t is an odd signal, remember. After this, we'll try to perform the third transformation of the independent variable, which is nothing but time scaling for this particular signal, signum function, right? So, let's go to the next transformation, time scaling operation. Time scaling operation. Here, time scaling operation, I want to perform like this. What is signum t? U of t minus u of minus t. Agree? Alright, from the first observation we got this one only, right? Now, scaling. What happens if I scale this signum t by alpha? Signum of alpha t. So, replace t with alpha. Alpha t minus u of minus alpha t. Or signum of alpha t is equal to u of alpha t is what? From the previous class discussion, u of alpha t is u of t minus u of minus alpha t is u of minus t. But u of t minus u of minus t is what? Signum t. Or signum of alpha t is nothing but signum t. Very, very good. Signum of alpha t is nothing but signum t. Right? Now, here what happens if I replace this t with minus t? Here, what happens if I replace this t with minus t? Signum of minus alpha t is equal to signum of minus t. Signum of minus alpha t must be equal to signum of minus t. From this, look here. If anybody asks you, what is the value of signum of 3t? Signum of 3t is nothing but what? Signum. Signum t. Right? Now, how I got this one? From this one on. Signum of alpha t is signum t, no? Right. Suppose if I ask you what is the value of signum of minus 3t? Signum of minus 3t. Apply this one. Nothing but signum of minus t. Can you write this as signum is odd function minus signum of t? Signum of minus t is nothing but minus signum of t because it is odd function. Right. Now, from this we'll try to get some more insights from this expression. What are those? Let's observe like this. Signum of alpha t is nothing but signum of t. Now, what happens if I replace t with t plus or minus t naught? If I replace t with t plus or minus t naught, what will happen? So, on the right hand side also, replace t with t plus or minus t naught. Now, here if you observe, this alpha has no significance. If you have a signum function of this kind, this alpha is having no significance, means if you ask me to get the shape of the signal, signum of 2t plus 1. Signum of 2t plus 1. How can I write this one? First of all, I'll try to bring this one in this form and I'll neglect the value of alpha. So I can write this as signum of, take 2 common, t plus 1 by 2. So neglect this value of alpha, that is 2. This is nothing but signum of t plus 1 by 2. Or signum of 2t plus 1 is nothing but signum of t plus 1 by 2. Can you, look here, can you prove this one? Or try to draw. Look here, we'll try, this is LHS, this is RHS. Now we'll try to draw both and we'll see whether this is correct or not. So how to draw signum of 2t plus 1? You can use first shift then scale. So signum of t is there with you. Go to signum of t plus 1, first shift. Call this as y of t. Scale this y of t by 2 units. So that you will get signum of 2t plus 1. So that you will get signum of 2t plus 1. So signum t is there with you. Signum of t plus 1. Signum of t plus 1 is advanced version or left shifted version. This is signum of t plus 1. Now this is, I am calling this as y of t. You have to scale this y of t by how many units? 2 units. Divide each point on the horizontal axis with the scaling factor. So this will become minus 1 by 2. Now if you observe, this is nothing but signum of t plus 1 by 2 now. Satisfied? Nothing but signum of t plus 1 by 2. Right? So this is an important one. You can neglect the value of alpha. In the same way, what is signum? If I replace t with minus t, already we have seen signum of minus alpha t. Signum of minus alpha t, what is that we got? Signum of minus t we got. Now here also what happens if I replace this t with the t plus or minus t naught? Signum of minus alpha t plus or minus t naught is nothing but signum of minus of t plus or minus t naught. Right? Now if I have a signum function of this kind, simply I can neglect this scaling factor alpha. I can neglect this scaling factor alpha. Now how you are going to prove this one? Look here. Suppose, or I can write this one like this also. You can bring the, this is an odd signal. This is nothing but minus signum of t plus or minus t naught you can write. Because signum is an odd signal, no? Right. So suppose if I have signum of, say, minus 2t plus 1. Minus 2t plus 1. So I can write this as signum of, take minus 2 common, t minus 1 by 2. Neglect the value of alpha. So discard this 2. So what will happen? This is nothing but signum of minus of t minus 1 by 2. And as our signal is a odd signal, I can bring this minus to the front. Minus signum of t minus 1 by 2. Okay. Now let's verify whether this signal and this signal are same or not. For that, again you can go with first shift, then scale. Let's observe. You must have somewhat patience, my dear students. Let's draw signum of minus 2t plus 1. First shift, then scale. Signum t is there with you. First shift, go to signum of t plus 1. Call this as y of t. Scale this y of t by minus 2 units. Minus 2 units. So that you get signum of minus 2t plus 1. Observe here. Signum t is there with you. This is signum t. Signum of t plus 1. Signum of t plus 1 could be advanced version of signum t by 1 unit. This is advanced version. Now you have to scale this by -2. Scale this by -2 means what will happen? See, you have to scale and you have to take the reversal. So it will come something like this. And this will become 1/2. This is nothing but signum of -2t plus 1. Now, we must see whether this is equal to minus signum of t minus 1/2 or not. Okay, let's verify. Let's draw minus signum of t minus 1/2. From that only, from this only directly we can say, but let's draw. So signum t is there with us. Go to signum of t minus 1/2 minus signum of t minus 1/2. So what will happen? Signum t is there with me. Yes, this is my signum t. Now signum of t minus half. Signum of t minus half means a delayed version of signum t by 1/2. Right? This is 1, this is -1, this is signum of t minus 1/2. For this, take amplitude reversal, mirror image along horizontal axis. What happens if I take the mirror image along horizontal axis? This will come like this, this will go like this. Observe whether you got the same answer or not. Yes, you will get the same answer. Right? In this way, you can experiment and gain knowledge on the transformations of the independent variable for a particular signal. If you observe, I am not doing any new thing. Whatever the existing things are there, I am utilizing. But remember, for these kind of things, you must have some patience. Independent variables. Right. So, time shifting we have seen. Time reversal we have seen, time scaling we have seen, and the combination of transformations also we have seen. Right. After this, okay, I'll ask you a question. If I ask you a question like this, observe here. The question is, this signal is given. What is this one? This is a rectangular pulse varying from -1 to 1. X of t is there. This is my signal. Now my question is, can you write this signal x of t in terms of signum? In terms of signum, can you write? Or we know how to write this signal in terms of unit steps. So, and we have the relationship between unit step signal and signum, so that the resulting signal can be written in terms of signum function. How? Observe here. First of all, write this signal in terms of unit steps. How we are going to write? At -1, there is a sudden rise, and that sudden rise is going with a value of 1, means start with u of t at -1. So, starting at -1, going with a value of 1 means what is that? U of t plus 1. U of t plus 1 is the signal. Starting at -1, going with a value of 1. Going with a value of 1. Because in unit step signal, coefficient indicates the value or amplitude. As this is going with a value of 1, when it encountered 1, its value became 0. So what value must be added to 1 to make it a value of 0? A value of -1 must be added. Value of -1. At what point it must be added? 1. Value -1 starting at t is equal to 1 means minus u of t minus 1. Right? Now I have written my x of t in terms of unit steps. Now the remaining part is left. Writing this signal x of t in terms of signum. What is the relationship between signum of t and u of t? Signum of t, we have seen, can be written as 2u of t minus 1. From this, u of t is nothing but 1/2 1 plus signum of t. Can I write like this? Yes, I can write. Now, x of t is equal to u of t plus 1. This is u of t plus 1 means 1/2 1 plus signum of t plus 1 minus 1/2 1 plus signum of t minus 1. Here 1 by 2 gets cancelled, or your x of t can be written as 1 by 2 signum of t plus 1 minus 1 by 2 signum of t plus 1. In this way, you can write the given signal x of t in terms of signum. Right? Okay. After this, I want one more signal whose definition is signum of cos t. Signum of cos t shape I want. How you are going to write? See, if you remember, similar kind of signals we have drawn in the case of unit steps also. U of sin t we have drawn. Now here signum of cos t. So if you want to draw the shape of signum of cos t, first of all you must be familiar with the definition of signum function. In what sense? Observe here. Signum t, how we are going to define? 1. Signum t is 1 for t greater than 0, minus 1 for t less than 0, and 0 at t is equal to. In a similar fashion, can you define what is signum of cos t? Signum of cos t. It is 1. In the place of t, you have cos t. It is 1 if cos t greater than 0. It is minus 1 if cos t less than 0. And it is 0 if cos t is equal to 0. Right? So let's draw. So first of all, if you want to draw signum of cos t, you must draw cos t. We are familiar with the shape of cos t, no? Cos t is this kind of shape. This kind of shape, cos t. What is the maximum value? Maximum value is 1. Minimum value is minus 1. Minimum value is minus 1. And what are these values? This will be pi by 2. This will be 3 pi by 2. 5 pi by 2. Minus pi by 2. Minus 3 pi by 2. Minus 5 pi by 2, and so on. And this is 0. This value is pi. This value is minus pi. This value is 2 pi. This value is minus 2 pi. What is this one? This is cos t. Now let's draw signum of cos t. In order to draw signum of cos t, what I will be doing is, I will be projecting the top values to the bottom. Like this. Minus pi by 2, 0. Pi by 2. 3 pi by 2. 5 pi by 2. Minus 3 pi by 2, and so on. See, from minus signum of cos t is 1 if cos t greater than 0. If you observe, from minus pi by 2 to pi by 2. From minus pi by 2 to pi by 2. Signum of cos t is greater than, cos t is greater than 0. So signum of cos t will be 1. It will take the value 1. Now, from pi by 2 to 3 pi by 2, its value is less than 0. So signum of cos t will take the value -1. And from pi by 2 to 3 pi by 2, cos t is greater than 0. So signum of cos t will take the value 1. And from -3 pi by 2 to -pi by 2, this cos t value is less than 0. So signum of cos t value will be -1. -1 and so on. So this is the shape of signum of cos t. Hope you're all comfortable. And it will repeat. So this is cos t, this is signum of cos t. Right? After this, we'll do one thing. I want the shape of u of 1 minus mod t multiplied with signum t. I want the shape of u of 1 minus mod t multiplied with signum t. And remember, before performing multiplication of signals is nothing but multiplying at common points, or multiplication of signals is nothing but multiplying at common instants. So if you want to multiply two signals, do one thing. Observe what is the common area present between those two signals, and among the common portion, you simply multiply the signals. Now u of 1 minus mod t, if you remember in the previous class we have drawn the shape of u of 1 minus mod t. It is simply a rectangular pulse varying from -1 to 1. This is u of 1 minus mod t. Already we have seen this in the previous class. Signum t. This is the shape. Signum is even function or odd function? Odd function. This rectangular pulse is even function or odd function? This is the even function. Because if I take the reversal, I'll get the same signal. Right. So, this is signum t, this is u of 1 minus mod t. Now multiply. And what I said, multiplication of signals is nothing but multiplying at common points or common portion. What is the common portion between these two signals? If you observe, the common portion is from -1 to 1. -1 to 1. After this, from -1 to 0, this value is 1, this value is -1. So 1 multiplied with -1 is -1. So -1. And here you have to close the signal. Close the signal. And from 0 to 1, this value is 1, this value is also 1. 1 multiplied with 1 is 1. Close the signal. So this is u of 1 minus mod t multiplied with signal. Right? So you can do one thing. You can take one homework. That is, you try to draw what is the shape of signum of sin t. Signum of sin t. You try to draw signum of sin t. Right. So this is about the second basic signal, my dear students, which is nothing but signum function. Signum function and its analysis. Okay. Let's switch to the next basic signal, which is nothing but a rectangular pulse. Rectangular pulse. Now, what is this rectangular pulse and how we are going to show this one? Observe here. I am going to show the rectangular pulse like this. This is what is your rectangular pulse. There is a generalized representation for this rectangular pulse, which can be given like this. So I am calling this as x of t. No? X of t is equal to, what is the amplitude? What is the amplitude? A What is the name we are saying? Rectangular pulse. So in short, rect. What is the independent variable? T minus centered. It is centered around 0 by overall pulse width. Overall pulse width is how much here? Minus t by 2. T by 2 means overall pulse width is t. This is the generalized representation. As this is, in this case, as this center is 0, I can simply write this as x of t is equal to a rect of t by capital T. A rect of t by capital T. Amplitude, name, independent variable by the overall duration. Amplitude, name, independent variable by the overall duration, or amplitude symbol. This is a symbol for rectangular pulse. Independent variable by the overall duration, or x of t is equal to, how can I write this one? X of t is nothing but a, the signal value is a, between minus t by 2 to t by 2, minus t by 2 to t by 2. Then what about at t by 2 and minus t by 2? See, we have discontinuities here. If you observe, we have discontinuities. How many discontinuities are there? 2 discontinuities are there. One is going in the upward direction and one is moving in the downward direction. Now, if you want the values at the points of discontinuity, what I told you, take the average of the values. So this is a by 2, this is also a by 2. So I can write this as is nothing but a by 2 at t is equal to plus or minus t by 2. Or you can write in this fashion also. X of t is equal to simply a for mod t less than t by 2. Mod t less than t by 2 means from minus t by 2 to t by 2, and it is a by 2 for mod t is equal to t by 2. In this way you can write. No sir, I want to write in terms of unit steps. Yes, you can write. How can you write in terms of unit steps? Starting at minus 2, we are having a sudden raise and going with the value of a means a u of t plus t by 2. As this is going with the value of a, when it encountered t by 2, its value became 0. So a value of minus a must be added. At what point? T by 2. This is in terms of unit steps. No sir, I want to write in terms of signum is. Yes, you can write, because you know what is the relationship between signum of t and u of t. You can write in terms of signum also. So this is the definition of rectangular pulse, which plays a major role. So what is generalized representation? Is the first representation amplitude, name, independent variable minus center. As center is 0, here independent variable by overall duration, or amplitude symbol, independent variable by the overall duration, or you can write like this. The third form. This is the fourth form. In whichever way you like, you can write your rectangular pulse. Right? And after this, what is the next job? Suppose, before going to that next job, if I ask you what is the shape of rect t? If I ask you what is the shape of the signal, x of t is equal to rect t. Rect means rectangular pulse. Here if you observe, center is 0. If you have center, it would have come after this t minus something is not there, means center is 0. So rect t, rect means rectangular pulse. Compare with the standard representation. What is the amplitude? 1. Independent variable is t. What is the overall pulse width? 1. 1 means what? Overall pulse width t means minus t by 2 t by 2. Overall pulse width 1 means minus 1 by 2 to 1 by 2. This is the shape of the signal. X of t is equal to rect t. Important. This is important. Rect t. This signal will come very often in our subject. Rect t. Right. Now let's perform the transformations of the independent variable on this rectangular pulse and observe what will happen, right? So what is the first transformation of the independent variable? Time shifting operation. Time shift operation. Suppose if you are given x of t is equal to rect t, x of t is equal to rect t, and you are asked to get what is x of t minus 1 and what is x of, sorry, it's not x of t minus 1, x of t minus 1 by 2 and x of t plus 1 by 2 they ask. Time shifting operation. How you are going to perform? So rect t means rectangular pulse varying from minus half to plus half. This is my x of t. X of t minus half means delayed version of x of t by 1 unit. 1 unit. Delay means right shift. So 0, 1 by 2, 1. This is x of t minus half. X of t plus half. Advanced version of x of t by 1 by 2. Advanced version means left shift. This is 0. This is minus 1 by 2. This is minus 1. Yes. We got the delayed version and advanced version for the signal x of t is equal to rect t. There is no problem. So shifting you can do. Next, go for the next transformation of the independent variable, which is nothing but time reversal. Time reversal. For every signal, we will make this kind of analysis. Time reversal. So time reversal means, suppose I have a rect of t by capital T is there, right? If I have a rect of t by capital T, what could be x of minus t? What could be x of minus t? X of minus t would be a rect of minus t by capital T. Minus t by capital T. So this is your rectangle pulse. Take the reversal. Reversal means mirror image along vertical axis. What happens if I take the mirror image along vertical axis? I'll get the same signal. I'll get the same signal. So how can you classify this one? Can I classify my rectangle pulse as an even signal? Yes, it is an even signal. Because if x of t is equal to x of minus t, we can call our signal as even signal. Even signal. Fine. Now, this will lead us to one more observation, that we found out a rect of t by capital T is same as a rect of minus t by capital T. Here if I replace t with t plus or minus t naught, this will become a rect of t plus or minus t naught by capital T will be equal to a rect of minus of t plus or minus t naught by capital T. Can I write like this? Yes. So whenever you're having this kind of notation, you can simply ignore this reversal because it is same as this one, right? So this is regarding the time reversal. Anyway, we'll observe this one while discussing the examples. After this, let's go for the next transformation, time scale. Time scale. And this time scaling we'll see with respect to an example. With respect to an example, we'll see. What is that example? Suppose if I ask you to draw the shape of the signal x of t is equal to 2 rect of 2t. Scaling is there now. So how we are going to draw? Rect t is there. So go to rect of 2t and after that amplitude scale by 2 units. So rect t is there with us. Go to rect of 2t. Go to 2 rect of 2t. 2 rect of 2t. Rect t means minus 1 by 2 to 1 by 2. This is rect t. Rect of 2t. Rect of 2t means what? Divide each point on the horizontal axis with the scaling factor. Scaling factor is 2, compressed version. What will happen? Minus 1 by 4 to plus 1 by 4. Rect of 2t. Now 2 rect of 2t means you simply amplitude scale this one by 2. Minus 1 by 4 to 1 by 4. This is your method. I'll follow a different method. See, what is that he gave? Xt is equal to 2 rect of 2t he gave now. Observe here. This is nothing but, can I write this as 2 rect of t by 1 by 2? Yes. Now if you observe, this came to a standard form. A rect of t by capital T with center at 0. So rect means rectangular pulse, center value is 0. So rectangular pulse. What is the amplitude? 2. What is the independent variable? T. And what is the overall duration? 1 by 2 means from minus 1 by 4 to plus 1 by 4. Observe whether you got the same answer or not. Yes, you will get the same answer. Right? In this way, also you can proceed. So one problem in our subject can be done in many number of ways, multiple number of ways. Okay, so let's go to the next part. Suppose if I ask you to draw the shape of the signal x of t is equal to 2 rect of 2t plus 3. How you are going to draw? 2 rect of 2t plus 3 means, yes, I can write like this. I want to put this one in a standard form. How? Xt is equal to 2 rect of, take 2 common, t plus 3 by 2. Or if I simplify this as 2 rect of t plus 3 by 2 by 1 by 2. Can I write like this? Happily I can write like this. Now this is in the form of rectangular pulse but centered at minus 3 by 2. So what could be the shape? Rectangular pulse centered at minus 3 by 2. Minus 3 by 2. Okay, fine. This is x of t. And what is the amplitude? Amplitude is 2. And what is the overall pulse width here? Overall pulse width is 1 by 2. 1 by 2 means this will be minus 3 by 2 plus 1 by 4. This will be minus 3 by 2 minus 1 by 4. Now if you observe, the overall pulse width will be 1 by 2. In this way you can draw this signal. Hope you are all comfortable with this. Now if I ask you this one, xt is equal to, if you observe here in these transformations, shifting is there, scaling is also there. Suppose if I put reversal also, 2 rect of minus 2t plus 3 if I ask you. 2 rect of minus 2t plus 3. So how we are going to simplify this? I am going to simplify this as x of t is equal to 2 rect of do one thing, take minus 2 common, t minus 3 by. Here minus is, as this rectangular pulse, as our rectangular pulse is even, this minus will not have any significance. You can ignore this minus, so that your x of t reduces as 2 rect of t minus 3 by 2 by this 2 I can write as 1 by 2. Or how to draw this one? Simply take the mirror image along vertical axis for this one, you get this one only. Centered rectangular pulse centered around 3 by 2. What is the overall pulse width? Overall pulse width is 1 by 2 means 3 by 2 plus 1 by 2, 1 by 4, sorry. This will be 3 by 2 minus 1 by 4. This is the rectangular pulse, what I am having. And this 2, amplitude is 2. In this way, you can draw the signal. Hope you are comfortable with these two. After this, I want to give you one more. Let's look at the next question. The next question can be given like this. So let's draw this signal. xt is equal to vector t plus 1.5, t plus 1.5, advanced version of vector t by 1.5 units, plus 2 rect of t by 2, okay, plus rect of t minus 1.5. I want to draw this signal. How I can draw this signal? Let's observe. First of all, what is rector t? Because all the expressions are involving rector t, no? So first of all, what is the shape of rector t? Shape of rector t can be given like this. This is rector t. Rector of t plus 1.5. Rector of t plus 1.5 would be advanced version of rector t by 1.5 units or left shifted version of rector t by 1.5 units. So do one thing, you drag this to the left by 1.5 units. What will happen? If I drag in that way, so this will come to, I think, minus 2, isn't it? This will come to minus 1.5 and this will come to minus 1. This is what is your rect of t plus 1.5. Hope you are all comfortable with this. Simply shift left this by 1.5 units. Right? Now 2 rect of t by 2. So to this, what you have to add? 2 rect of t by 2. Rect of t is this one. Rect of t by 2 with divide the scaled version is an expanded version of rect t because the scaling factor is less than 1. No? So divide each point on the horizontal axis with the scaling factor and that will become what? Minus 1 to 1. Minus 1 to 1 but with the amplitude of 2. 2 rect of t by 2, no? Plus to this what we have to add? Rect of t minus 1.5. So simply shift right this rect t by 1.5 units. So this will go to 0. No, this will go to 1. This will go to 1.5. This will go to 2. With an amplitude of 1. Right? Now we have, let's add. What happens if you add these three? The resulting signal will exist from what value to what value? Minus 2 to 2, minus 2, minus 1.5, minus 1, 0, 1, 1.5, 2. Right? Vector of t plus 1.5. Okay, right. Now, if you observe here, from minus 2 to minus 1, from minus 2 to minus 1, what is this value? 1. This value is 0. and this value is also 0. So what will come from -2? Let me use the other color. From -2 to -1, my dear students. From -2 to -1, this is 1. This is 0, means 1 I'll get. 1. From -1 to 1. So from -1 to 1, what is this value? This value is 2. This value is 2, and this value is 0. This value is 0. This value is 0. So what will happen? 2 I'll get. 2. This value is 2. And from 1 to 2, if you observe, from 1 to 2, this value is 0 and this value is 1. This kind of signal you are going to get. Hope you also got the same answer. This is what is your xt. Clear? Now we'll do one thing. What I will do is, I want the shape of this signal rect of t by 2 plus rect of t by 4. Rect of t by 2 plus rect of t by 4 shape I want. Now how to draw the shape? Rectity, you know. Rectity means rectangle pulse varying from what value to what value? -half to +half with a value of 1. Now rect t by 2. Rect t by 2 means expanded version of rect t. So divide each point on the horizontal axis with the scaling factor. Scaling factor is 1 by 2. So what will happen? So rect of t by 2 will exist from -1 to 1 with a value of 1. This is rect of t by 2. Now let's draw rect of t by 4. Rect of t by 4 means expanded version of rect t. So divide each point on the horizontal axis with the 1 by 4. So this will become -2. Right? Now what we have to do? We have to add these two signals. Now what happens if I add these two signals? So this existing from -2 to +2 and this existing from -1 to 1. Now let's add. So the resulting signal definitely exists from -2 to +2. From -2 to -1, this value is 0, this value is 1. So 1 I am going to get. From -1 to 1, this is 1, this is 1. 1 plus 1 is 2. From 1 to 2, this value is 0, this value is 1. 1 you are going to get. So this is the shape of the signal. Now if you observe, this has the same shape as the previous one. Observe, same shape we got, isn't it? So one problem can be done in many ways. Now the same problem, look here, the same problem can be done like this also. If you observe, if I ask you to draw the shape of the signal, xt is equal to rect of -t minus 1.5 plus 2 rect of t by 2 plus rect of -t plus 1.5 I ask you. In my view, this must be also of the same shape as the previous one. Why? Because we can simplify now. Here, how can you simplify this? X of t is equal to, you can write this as rect of, take minus common, t plus 1.5 plus, this is nothing but 2 rect of t by 2, don't change this one, plus rect of minus of t minus 1.5. As the rectangle pulse is an even signal, already we have seen that this minus will not have any significance. So you can ignore this minus and you can ignore this minus. So that your signal x of t can be written as rect of t plus 1.5 plus 2 rect of t by 2 plus rect of t minus 1.5, which is same as the previous one. You can verify also. This one. Same expression we got. So if I try to draw, I'll get the same shape. Right? Now, after this, what is the other signal I want? I want the shape of the signal x of t is equal to 2 rect of minus 4t plus 8 by 16. This shape I want. All of you try this one. 2 rect of minus 4t plus 8 by 16 I want. Now how you are going to solve this one? Any idea? You have to make use of the standard rectangular pulse expression to get this one. How? Observe here. I can write this as 2 rect of, take minus 4 common, t minus 8 by 16. Right? Whenever you have minus here, this doesn't have any significance in this rectangular pulse, so that I can ignore this minus, and the remaining thing I can modify like this. This is nothing but 2 rect of t minus 8 by 4 I can write. So how you are going to draw this one? Rect means rectangular pulse. Here center is 8. Centered around 8. Up. So overall pulse width is 4. Overall pulse width is 4. Means 8 plus 2, 10. 8 minus 2 is 6. Amplitude is 2. This is the shape. This is it. X of t. Centered around 8. Overall pulse width is 4. Rectangular pulse with an amplitude of 2. Hope you are all comfortable with this. Now this is about your rectangular pulse. Now we'll do one thing. Let's switch to the next basic signal. That is nothing but triangular pulse. Triangular pulse. How we are going to show this triangular pulse? I can show like this. Triangular pulse means the shape is, the signal shape will be in the form of a triangle. Independent variable is t. This is 0. This is a. This is x of t. Now, is there any generalized representation as that we have in rectangular pulse? Yes, we do have a generalized representation, but that is given by x of t is equal to, what is the amplitude? A. Name triangular pulse, not tri. Tri. Independent variable. So here this is minus t, this is t. Independent variable is small t by, remember, in triangular pulse generalized representation, we won't be taking the overall pulse width, but we'll be taking only the half pulse width. This t is half pulse width. Half pulse width. In rectangular pulse, we'll be considering the overall pulse width, whereas in triangular pulse, we'll be considering only the half pulse width. This width only we'll be considering in the representation. Right? Now, this is one form of representing. And from this, if I ask you, what is the shape of the signal x of t is equal to tri t? Tri t if I ask you. And remember, I forgot to tell you, my dear student, that here you can consider this as, here I'll do one thing. Observe here. If I remove this one, here t minus center, t minus center. Here as center is anyway 0, you can put center also here. T minus center by overall duration, and as the center is 0, a tri of t by capital. Hope you are comfortable. Now if I ask you what is the shape of the signal, tri T. Tri T means what? Tri means triangular pulse. Tri means triangular pulse. Center is 0. What is the amplitude? 1. Independent variable is T. By 1. Half pulse width is 1. So this is 1, this is minus 1. So this is the shape of the signal tri T. So rect T we have seen, tri T we have seen. Now there is one more representation here. For that, if I ask you what is the equation of this line, see many times in signals subject you are asked to, or you must calculate what is the equation of these lines, this line or this line. Now how you are going to calculate? So this is in the form of, if you observe, this is in the form of y is equal to mx plus c. Y is equal to mx plus c, where m is the slope, x is the horizontal axis, and c is the intercept on the vertical axis, right? So x is the independent variable, y is the dependent variable. Now if I want the equation of this line, now how can I write the equation of this line? So what is the slope here? What is slope from minus t to 0? Slope is what? Vertical coordinate by horizontal, no? So here, observe here, height is how much? A, width is t, and this is increasing, means slope is positive. Slope is a by t. So what will be the equation of this line? X of t is equal to y is equal to mx. M means slope. Slope is what? A by t multiplied with the independent variable plus what is the y? What is the intercept along vertical axis? Now this line is touching the y axis at a, no? Or this is a into 1 plus t by t. So this is the equation of this line. In the similar fashion, if I want to find out the equation of this line, now what is the slope? Slope is, height is a units, width is t units, this is decreasing, slope is minus a by t. So x of t is equal to y is equal to slope. Slope is minus a by t, dependent variable, plus this line touches the vertical axis at a, or the equation of this line becomes a into 1 minus t by t. The equation of this line is a into 1 plus t by t, and the equation of this line is a into 1 minus t by t. So combining those two, what can I write? X of t is equal to the next representation. Can I write this as a times 1 minus mod t by t. Mod t by t. Mod t means from 0 to t. Because if I take from 0 to t, here t becomes positive, so that I will get equation of this line. If I take from minus t to 0, so mod t will become negative. Independent way, this will become negative. Negative means I will get equation of this line. So this is the equation of this triangular pulse between mod t less than t. Mod t less than t. Try to remember this one. This is the representation, one more representation. Mod t less than t means from minus t to t. This is the behavior of the triangular pulse. Okay, fine. After looking at the definition and the expressions, now transformations of the independent variable. What is the first transformation you can perform? Time shifting operation. So time shifting operation, you observe. Try to get the shapes of the signals. Tri of t plus 1, tri of t minus 1. Tri of t plus 1 means what? Tri of t plus 1 is advanced version. Advanced version of tri t by how many units? Advanced version of tri t by how many units? 1 unit. Means simply shift left the signal tri t by 1 unit. So tri t means centered around. Tri t means just now we have seen. No, tri t means centered around 0. Now this will be shifted to the left by 1. This is try t plus 1. Hope you are all comfortable. Try t minus 1. Delayed version of try t by 1 unit. Simply shift right the signal try t to the right by 1 unit. This is what you are going to do. Okay, time shifting is done. After this, time reversal. Time reversal. While discussing time reversal, suppose I have this one. X of t is equal to a try of t by capital T. From this, you try to get the reversal of x of t, that is nothing but x of minus t. Reversal means what? Mirror image along vertical axis. So, this is triangle pulse. This is a try of t by capital T. This is x of t. Now, x of minus t. X of minus t would be a try of minus t by capital T. Minus t by capital T means take the reversal, mirror image along vertical axis or folding the signal along vertical axis. Now, if I take the reversal, if you observe, you are going to get the same signal. X of t and x of minus t are same. Means what is your conclusion? Your conclusion is that try t, triangular pulse, is a even signal. So, triangular pulse is a even signal. If it is a even signal, what can you do? Many things. A try of t by capital T can be written as a try of minus t by capital T. No, if I replace t with plus or minus t naught, so a try of t plus or minus t naught by capital T is equal to a try of minus of t plus or minus t naught by capital T. So whenever you have this kind of expression, so you can simply ignore this negative sign because triangular pulse is an even signal. Triangular pulse is an even signal, right? So this is about the time reversal. The next one is time scaling. Time scale. Scaling means what? Multiplying independent variable by a constant. Multiplying independent variable by a constant. Suppose if I ask you xt is equal to 5 try of 5 by 2t. 5 try of 5 by 2t if I ask you, then how you are going to perform? Try t is there, no? Try t is there. So scale that try t. So try t is there with you. Try t. Now what you have to do? Scale try t by 5 by 2. So which will be a compressed version. And after that you calculate 5 try 5 by 2. Try t means what is the shape? This is the shape. This is try t. Now try 5 by 2t means divide each point on the horizontal axis with the scaling factor. What will happen? This will become minus 2 by 5, this will become 0, this will become 2 by 5. Isn't it? Now 5 try 5 by 2t means minus 2 by 5, 0, 2 by 5 and it becomes 5. This is one method, but I have different approach also. So what is that approach? Observe here. Xt is equal to 5 tri of 5 by 2t. Can you put this one in the standard rectangular pulse format? Yes, I can put. How? Observe here. I can write this as 5 tri of t minus 0 by 2 by 5. Can I write like this? Yes. Now, this is in the form of standard triangular pulse, but centered at 0. So, centered at 0 means like this. Here, this 2 by 5 represent what? Half pulse width. In triangular pulse, it represents half pulse width. So, as this is even, this will be symmetrical along vertical axis. Let's verify whether we got the same answer or not. Yes, we got the same answer. You will get the same answer. So, one problem can be done in multiple number of ways. That is the beauty of our subject. Okay. So, after this, I want one more. Xt is equal to 2 tri of t by 2 t by 2 plus 1. 2 tri of t by 2 plus 1. Can you arrange this one in a standard form? Yes, but before this, let me write this as 2 tri of t plus 2 by 2. Here, centered, this triangular pulse is centered at minus 2. So, this will come like this. Triangular pulse centered at minus 2. Half pulse width is 2. So, come like this. Hope you are also getting the same answer. This is your exam. See, parallel you must try with me. Then, after that you can check. Simply listening the class makes no sense to my dear students. You have to parallel do with me. Right? And suppose if I ask you one more. Xt is equal to 4 tri of, suppose if I ask you minus 2t plus 4. 4 tri of minus 2t plus 4. How you are going to solve this one? Here, I can simplify this as xt is equal to 4 tri of, take minus 2 common, t minus 2. And as our triangular pulse is an even signal, this minus will not have any significance. So, ignore, neglect, or further, we can simplify our x of t as tri of, t minus 2, sorry, 4 tri of t minus 2 by 1 by 2. Can I write like this? Yes. Now, let's draw this one. So, this is nothing but a triangular pulse centered at 2, with half pulse width 1 by 2. So, 2 plus 1 by 2, 5 by 2. So, 2 minus 1 by 2, 3 by 2. This is the shape of the triangular pulse. Hope you also got the same answer. Right? So, in this way, you can draw triangular pulse for various transformations of the independent variable. Now, the next part, what I am going to discuss is an interesting part. That is, I want the shape of the signal xt is equal to rectity plus tri-t. I want the shape of the signal rectity plus tri-t. How you are going to do? This is an interesting example. Now let's perform. First of all, before solving this one or before getting the shape of the signal x of t, you must know what is the shape of rectity and what is the shape of tri-t. See, rectity can be shown like this. Rectity means it is a rectangular pulse varying from minus 1 by 2 to 1 by 2. This is rect T. Try T. This is the shape. Now we have to add these two. We have to add these two and we must show the resultant shape. Now how we are going to get addition? We'll do one thing. So here between, if I project the values, between minus 1 to minus 1 by 2 this is 0, and between 1 by 2 to between 1 by 2 to 1 also this value is 0, this has some value. Now what is the equation of this line? What is the equation of this line? I told you how to calculate the equation of this line. Y is equal to mx plus c. So m is what? Slope. Slope is what? Vertical by horizontal. Slope is slope is 1, vertical by horizontal. So slope is 1. Mx means independent variable plus c. C means the point where this line touches the vertical axis. Vertical axis intercept 1. So the equation of this line from minus 1 to 0 is t plus 1. In a similar fashion, so this equation. Now what will happen? Now this is a decreasing means negative slope. First of all, what is the slope? Y coordinate by x coordinate, it is minus 1. So minus independent variable is t plus the point where it touches the vertical axis 1. Right? Fine. Now let's add. I'll do one thing. I'll try to show the resultant here. I'll try to show the resultant here. The resultant signal is, I will show you. Definitely the resultant signal will exist from what value to what value? Minus 1 to 1. And before going to calculate the resultant signal, let me tell you, or let me give a small recap that these two are even signals. This is the even signal. This is also even signal. Already we have seen, no? Even signal means anyway we have separate discussion. They will be symmetrical along vertical axis. They will be symmetrical along vertical axis. Now let's add. From minus, observe here, from minus 1 to minus 1 by 2. From minus 1 to minus 1 by 2, what is the equation of this line? The equation of this line is t plus 1. What is the equation of this line? 0. So 0 plus t plus 1 is what? T plus 1. So in the resultant, from minus 1 to minus 1 by 2, we must get t plus 1. T plus 1 means what will happen? If I put minus 1, it will be 0. In t plus 1, substitute the value of t to be minus 1. It will become 0. So what happens if I substitute minus 1 by 2? Minus 1 by 2 plus 1. T plus 1, no. T value is minus 1 by 2. Minus 1 by 2 plus 1? 1 by 2. So 1 by 2. This value is what? 1 by 2. Draw the line. Let t plus 1. Now, look here. If you observe, at minus 1 by 2, there is a sudden jump here, discontinuity. There is a sudden jump, discontinuity. Always remember, whenever you have a discontinuity in one signal, whenever you are adding or subtracting, that discontinuity will be carried. So, in the resultant signal also, I will have a jump to discontinuity at minus 1 by 2. And what is the height of this discontinuity here? 1. So, here I will have a jump discontinuity like this at minus 1 by 2. Now, between minus 1 by, now you have to consider from minus 1 by 2 to 0. Minus 1 by 2 to 0, what is this one? This is 1. This is t plus 1. 1 plus t plus 1 is what? T plus 2 only. See, between minus 1 to 0, this is 1. This is t plus 1. 1 plus t plus 1 is t plus 2. So, the resultant signal will have the value of t plus 2 between minus 1 by 2 to 0. What happens if I substitute? So, if I have jump discontinuity of 1 here, so here this will be 1.5. 1.5. No? Now look here. Minus 1 by 2 to 0, this is 1, this is t plus 1. So, t plus 2 will come. T plus 2 means, observe here. What happens if I substitute minus 1 by 2? Minus 1 by 2 plus t plus 2. Sorry, minus 1 by 2 plus 2. 1.5. Satisfied? What happens if I substitute 0? 0 plus 2. 0 plus 2 is 2. Right? Now, I got the shape of the resulting signal for t less than 0. T less than 0. And remember, my dear students, this is even signal, this is even signal. Always, if you add two even signals, the resulting signal will be an even signal. If you add two even signals, the resulting signal will be again an even signal. Even signal means what? If I know for t less than 0, I can construct for t greater than 0 also. Symmetrical portion will be having. So, like this, like this. This is the shape of the signal xt. This is rectity plus tri-t. In this way, you have to draw the signal. Hope you are all comfortable with this. Shall I repeat one more time? Observe here. From -1 to -1 by 2, this is t plus 1, this is 0. So here t plus 1 is carried. This t plus 1 is carried. Right? Now, from -1 by 2 to 0, first of all, there is a jump discontinuity. So carry that in the resulting signal. And from -1 by 2 to 0, after this jump discontinuity, this is 1, this is t plus 1. So this will be t plus 2. T plus 2. So t plus 2, what will happen if I substitute -1 by 2? 1.5. What happens if I substitute 0? It will be 2. So after getting this one, what I am saying, if you are adding two even signals, the resulting signal will be an even signal. Means if I know the portion of the signal for t less than 0, I can draw the portion of the signal for t greater than 0. Symmetry, because of symmetry, even symmetry. Right? Now I'll do one thing. Hope you are all comfortable with this. If you are comfortable, I want the shape of this signal. Rectity minus tri-t. Rectity minus tri-t. In the previous case, rectity plus tri-t. Now rectity minus tri-t. Let's draw the shapes of the signals and observe. Rectity means, even though if you have not understood the previous one, try to understand from this example. Rectity means a rectangular pulse varying from -1 by 2 to 1 by 2. This is rectity. Tri-t. Tri-t means the triangular pulse varying from -1 to 1. Do you know what is the equation of this line? Mx plus c, slope is 1 multiplied with the independent variable. Independent variable is t here. Independent variable is t plus intercept along the vertical axis. This is 1. This is minus t plus 1. Now, what is the operation involved? Subtraction. Subtraction. You have to subtract the bottom signal from the top signal. You have to subtract the bottom signal from the top signal. So this is -1. This is 1 here. So resulting signal, I'll try to draw here. Resulting signal I'll draw here. This is my x of t. I'll call the resulting signal as x of t. And before calculating the resulting signal, let me tell you that this is an even signal. This is also an even signal. And if you subtract two even signals, the resulting signal will be an even signal. If you subtract two even signals, the resulting signal will be an even signal. And the beauty of this even signal is that if you know the portion of the signal for t less than 0, you can build the portion of the signal for t greater than 0. Now let's see how we are going to build. Right. For t less than 0, what is the value of this signal? For t less than 0, this is 0. This is t plus 1. So, -1, -1 by 2, 0, 1 by 2, 1. Right. This is 0. This is t plus 1. What happens if you subtract t plus 1 from 0? From here to here, if you observe, this is 0. from here to here, this is t plus 1. 0 minus of t plus 1, minus t minus 1, minus t minus 1. So minus t minus 1 means what happens if I substitute, minus 1, 0. In minus t minus 1, if I substitute minus 1, it will become 0, right, 0. In that minus t minus 1, okay, here I'm writing, in that minus t minus 1, what happens if I substitute minus 1 by 2? Minus 1 by 2, if I substitute minus of minus plus 1 by 2 minus 1, minus 1 by 2. Minus 1 by 2 means here, minus 1 by 2. Draw the line, right? After this, what happened at 1 by 2, sorry, from minus 1 by 2 to 0, we have a jump discontinuity here. And I told you, wherever you are going to have jump discontinuity, in the resulting signal also will have jump discontinuity. Now what will happen with the jump discontinuity? So I'm going to get the jump discontinuity, because the jump discontinuity is of the value 1. So from minus 1 by 2 to 1 by 2, jump discontinuity came. Now immediately after minus 1 by 2, from minus 1 by 2 to 0, from this point to this point, what is this signal? This signal is 1 and this signal is t plus 1. This signal is t plus 1. What will happen? 1 minus of t plus 1. 1 minus of t plus 1. It is nothing but minus t. So from minus 1 by 2 to 0, the resulting signal has the equation of minus t. Means if I substitute minus 1 by 2, 1 by 2, what happens if I substitute, say, 1 by 4? If I substitute minus 1 by 4, so between minus 1 by 4 lies between minus 1 by 2 to 0 now. So if I substitute minus 1 by 4 means this becomes 1 by 4, half of this one. And if I substitute 0, right, now if I subtract two even signals, the resulting signal will be an even signal, and I know the portion of the even signal for t less than 0. So immediately I can draw the portion of the signal for t greater than 0 with symmetry. This kind of shape. Okay. Hope you are all comfortable with this. Suppose if I ask you, what is the shape of the signal? Try t minus rect t. Try t minus rect t if I ask you. Now how you are going to draw this one? You need not draw. You can do one thing. Minus of rect t minus try t. So already we have rect t minus try t now. So for this signal, take 180 degrees phase shift. Take the 180 degrees phase shift means what? Take the mirror image along horizontal axis. Take the mirror image along horizontal axis for this signal, you get try t minus rect t, and is as simple as that. So rect t plus try t we calculated, rect t minus try t we calculated, try t minus rect t we calculated,